continue, I need to write 2 notes for you. So note number 1. I'll come back to that page. Note number 1. All terms without age must simplify in the numerator, regardless of the function. No matter what the function is, quadratic, rational, cubic, whatever, at the top of the difference quotient, all terms without age must disappear. Sometimes more than just those terms will disappear, which is fine. But all terms without age must disappear. If they don't disappear, something is wrong and I can't continue. So this is note number 1. After that, in this particular order, note number 2, age from the denominator after this first step happens, age from the denominator must simplify. If it does not, then I know something is terribly wrong and I have to start from scratch. So all terms without age must simplify in the numerator. And 2, age from the denominator eventually at the end must go away. Okay, so what can I simplify in the numerator? Please tell me, what would you simplify in the numerator?
All the ages.
Okay.
You would simplify, you would cancel out x squared, negative x squared,
Excellent.
and 3x,
Yes.
negative 3x,
Excellent.
and positive 6, negative 6.
Excellent. So all terms without age are gone. This has age, this has age, this has age. All terms without age are gone. Now, these 3 terms have a common factor. Which common factor I have to pull out from all 3?
You will, sorry, go ahead. Oh, sorry, it would be 8.
Very good. Can you please tell me what is left in parentheses? What is
2x plus 3.
There are 3 terms. There are 3 terms. You have to give me 3 terms.
2x plus 8 plus 3.
So 2x plus,
H.
very good, plus,
3.
exactly. So all terms without age are gone. And now age from the denominator must disappear. What do I need to do next? What do I do next?
You cancel out the h.
Simplify age with age. What is the final form? Simplified form of the difference quotient for this particular function. Can anyone dictate?
2x plus h plus 30.
And you can say, how does this change into the instantaneous velocity? You have to wait till chapter 1. This will change. This will become the not now. There is something else we need to add here. This is not it yet, but this is close to being the instantaneous rate of change, the slope of the tangent line, and the instantaneous rate of change that I was talking about, that 62 miles an hour passing through Wilmington. Not yet. We're not there yet. That's why this is so important. Questions, please. Anything you'd like to say, discuss, analyze, anything, please. Do we need another example? These two steps must happen for any function that you determine and simplify the difference quotient. Please let me know. So this was a quadratic function. I think we should look at a rational function and then continue. Is that okay with everyone?
Yeah, that's fine.
Perfect.
Yes, that's okay.
Perfect. Can anyone give us a rational function? If not, I will make one up. Okay, so let's say x plus 1 over x minus 1. This is a rational function, a very simple rational function. Same question, find the difference quotient. So the difference quotient, as we know, is f of x plus 1. I'm sorry, f of x plus h, I meant to say, minus f of x divided by h. Okay, so I can continue directly. I don't have to work on this separately because it's much easier. Easier in the sense that it's not as long as this one was. So, can anyone give us f of x plus h? This is already here. This is already here. I need to determine this. Can anyone help us with f of x plus h?
X plus h.
Yes.
Parentheses.
There is no need the parentheses, but you are correct. It's not wrong, but we have the nothing in front. So indeed, x plus h plus
1.
Excellent. If we do have a 2, then yes, or a 5 or whatever, then yes, I would have. It's not a mistake to put parentheses, though. And the denominator?
And then x plus h minus 1.
That's it. Perfect. Awesome. Thank you so much, Marcus. Okay, now, if you remember, what will be the next step? Can anyone tell us what to do in the numerator? We have to perform something there before we continue.
Get rid of all the values that don't have h in it.
Ah, very good point, but we are not at that stage yet. Very good. Yes, but we're not there yet. We haven't simplified yet.
We need common denominators.
Brilliant. Thank you very much. We need the least common denominator. Excellent. So this is one denominator, and this is the other denominator. Can anyone tell us what is the least common denominator? And I'm going to give you a hint. Yes. If you want to say something, please go ahead. I'm looking for...
Is it h?
So I'm looking for some, my props. These are my props. This is a denominator, and this is another denominator. They have nothing in common. This has nothing in common with this. When I say common, I mean common factors. There are no common factors. So what is the least common denominator when I have two denominators that have no common factors? What would be the common denominator of 1/2 minus 1/3? 2 and 3 don't have common factors. What is the least common denominator of...
486.
Exactly. They have nothing in common. So one more time. What is the least common denominator of these two since they have no common factors?
-1.
No common factors. So why didn't you say here 5? You said 6. Why didn't you say 5 or -1? Here you said 6, right? You said the least common denominator is 6. Why are you saying here -1? when they have nothing in common. That's why I covered them so you don't even look at them. They have nothing in common, no common factors whatsoever. It's exactly like 2 and 3. What do you
Is
think?
it positive 1?
So is the least common denominator here positive 1?
No.
No. It's in exactly the same.
Is it 6?
So it's the same procedure. We have to apply the same procedure. What was the procedure of finding 6?
You just multiply by like the other one.
Exactly.
So like 2 times 3, 3 times 2. It'll be x plus h minus 1 times x minus 1.
Absolutely. It's the only way. It has to be the product of the two. Absolutely. That's why I gave you this tiny numerical example so you understand when I say they have nothing in common, the least common denominator must be the product of the two. There is no discussion there. So 2 and 3 have no common factors. So the least common denominator is 2 times 3. The same thing here. This looks more complicated because it has x and h, la la la. But it's the same procedure. No common factors. The least common denominator must be the product of the two. Awesome. So then, what do I multiply the top by? What do I multiply the top by? So what did you multiply 2 by to get this?
I'm sorry, can you repeat the first question?
Yes. What did you multiply 2 by to get 6?
Oh, about times 3.
Good. What did you multiply 3 by to get 6? 2. Same procedure. Exactly the same. Why do I multiply the top by?
X minus 1.
Exactly. Same thing. What do I multiply the top of this fraction by?
X plus h minus 1.
That's it. Why is that? Why is that? Because this was multiplied by x minus 1 to get this product. I have to multiply the numerator by the same quantity. This was multiplied by x plus h minus 1. So then I have to do the same thing to the top. It's mandatory. So now careful how we distribute, because when we multiply this by this, we have to use the distributive law. X distributed to these three, and -1 distributed to these three. So x times x, x squared, x times h, xh, x times 1 plus x, minus 1 times x, minus 1 times h, minus 1 or -1 times 1. This product is this. Now I have to multiply this quantity by this quantity. Distributive law again. X times x with minus in front. X times h with minus in front. X times -1 with minus in front. 1 times x with minus in front. 1 times h with minus in front. 1 times -1 with minus in front. So this product with minus in front is this. Now, in order to finalize this, I have to make sure that all terms, I don't cross out if they are not there, right? If I can cross them out. But I have to make sure that all terms without h must go away. And then the end step. Okay, now, can anyone tell us what to do in the numerator? What goes away? I'm ready.
Would that be x squared?
Excellent.
X, negative x,
Yes?
and is that all for the numerator? Or is it -1 and +1?
What else? It happens that even two terms with h go away. Awesome. That's even better. Positive xh with negative xh. Let's see what is left. Da, 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 da. Da, 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 da. So, what is left in the numerator?
Negative h squared.
Careful. Minus an apple is not minus apple squared. Minus an apple equals,
-2h squared?
yes, no, not squared.
Or I mean -2h.
Negative 2h, perfect, over x minus 1, x plus h minus 1 times 1 over h. We divide two fractions in the following way. We copy the fraction from the top and we multiply it by the multiplicative inverse of the denominator. H is the same with h over 1, so when I flip it, it's 1 over h. So I'm happy that the first note happened. Now, does the second note happen? If it doesn't, then I'm in trouble. Does it? So, yes or no?
Are we able to do the same technique that we did with the numerator?
Of course, we simplify by h. I simplify the numerator by h. I simplify the denominator by h. It's done. So then the simplified form is negative 2 over x minus 1, x plus h minus 1. Both conditions were fulfilled. One condition was all terms without h went away from the numerator. Even extras went away. Awesome. I'm even better. I'm even happier. And at the end, the h from the denominator went away, as I expected. I never said that the final form will not have h in it. I never said that. I never said that the final form will not have h in it. It must, but not the h from the denominator. So it does have an h at the end, but not this one. A totally different one. You can say, but it's the same. I agree, but not this particular factor. These two go away. So this completes R.1 and R.2. I'm trying not to spend hours and hours and hours on review, but